All right, we'll get started. Sorry, it's a little dark. The projector, dark and wet. The projector doesn't the brightest, so we keep the light down so hopefully you can see the presentation. And most of you know us, but we're Christy and Perry from Muskoka Canadians for Truth, and we're happy to have you here tonight. And we're really glad you could phone on a rainy Tuesday night to see our presentations. Couple things just to get started. You probably noticed some water and snacks back there. The washrooms are out that way. Peggy's plants are back there if you'd like to purchase some of her plants. You see Peggy. This is something we're going to try. As I said, I stole this from the Burst Falls group last week, where they have a barter table at their meeting. So we'll maybe try this coming forward, so people can bring things to trade and sell. So so we'll give that try that out in the next couple of meetings. Just briefly before we get started, we thought we'd bring your attention to this wonderful graphic that I spent years putting together. This is kind of our strategy for 2024. We're hoping to, you've probably seen this on the emails, I'm sorry, it's probably hard to read. But what we're trying to achieve a little bit this year is to make some traction in some key areas, particularly health, preparedness, sovereignty, and education. I have to look at my own slide to remember what's written down.
All wrapped up as a community, which is what glue, it has the glue to put it all
Glue
together.
is the community, yes. So, and linking all those things together are communication and funding, which, so what we've been doing over the last few weeks, Chris and I, is trying to find some leaders for a committee on each of those, the four main bubbles. And we think, all those pieces in place at the moment. So we're looking for people, if you're interested in any of those particular areas, and we'll announce the winners of the committee lead, and to contact them. Maybe 1 or 2 hours a week is all we're really looking forward to, just to try and make some progress in these areas, okay? So that's...
And it'll be small group meetings in person, so it's a really nice way to get to know people. Most of the committee meetings will be, right, small group meetings. Some might be Zoom, but whatever the team lead wants to do. But I know that the ones we've talked, most of them try to do it in person. Yeah. So it's a great way to get involved in something that, you know, where your interests lie. And, you know, again, it's maybe on average 1 or 2 hours a week, but some weeks it's nothing, and other weeks it might be a little bit more. And if you can't do it some weeks, you can't do it. You know, it's all volunteers. So it's just a great way to get involved and make us all a bigger community, more engaged.
Yeah, try and actually maybe achieve something. So
if you're interested, you can email us at our, just respond to the newsletter and what area you'd be interested in, and we'll get connected to the...
so any minute now I'm going to update our website to reflect this too, so you'll be able to find that information there as well, particularly who's doing what. So that information will be there soon. Okay, is there anything else?
I think that's it. If anybody else has anything...
The future presentation coming up in June?
Yeah.
Steve?
Yeah. So this summer we have some other speakers coming up. Donald Lee and together with Tish Conlon will be here on the
June 14th.
14th of June. So I look for that. So Donald was one of our most enjoyed speakers last year. Tish as well. So that's another joint. That'll be a fun night. And then Dave and I think.
We don't have a date yet, but Brett Hawes, who was at the WHO meetings overseas, is going to come and give us an update on what went down there. And I don't know if people have heard. If people have heard, but apparently they haven't reached an agreement. So again, we're going to keep trying. We're going to keep trying. So we've got to
start.
Yeah, so there's a big event in Geneva this weekend, June 1st, where people from all over the world are converging in Geneva the headquarters of the WHO and are basically meeting, protesting, etc. So Brad Hawes, who is now a director of Children's Health Defence Canada. Children's Health Defence is the group headed up by Robert Kennedy Jr. in the States, but they have a Canadian branch, and who made Sherry St. Louis, is that right? She lives just over, she has a place just up in French River area too. So, Brett, if you haven't seen Brett, he's awesome too. He's on the health side, he's great, and so we're really looking forward to having him here later in June. So probably this is that term. So okay, thanks for that, Steve.
And then we have we've been talking with Veterans for Freedom. So we're going to be arranging some workshops, more around the lines of preparedness type issues and topics, where you can get sort of hands-on, and so we're really looking forward to bringing that to you as well. That'll be obviously under the preparedness.
Yeah, so they do a lot of like 4 or 5 hour workshops on preparedness and hands-on stuff. So that's
Food security.
Food security.
Food security is a big group, yeah. Do not. Their motto is do not comply, it's do not rely. So don't rely on the existing food sources. And then lastly, we were also talking to Canadians for Truth people in Alberta last weekend, I guess it was, and we're still trying to get Theo Fleury and James Slay and Joseph Brogo here for a Fire and Ice session in the future.
In the future,
So,
we're working on it.
We're working on that. So there's lots of stuff happening already in the early summer. All right.
Well, without,
Yeah, so next, so that brings us to our headline speaker. So Professor William van Winjgaarden, Bachelor of Science in Computer Science and honors Bachelor of Science from University of Windsor in 1982, followed by a Master's and PhD in Physics from Princeton in 1986, and has been a professor at York University for the past 36 years. He's a contributor to CO2coalition.org, a signatory to clintel.org, and he was advisor to the Ontario government as well. So I'll let him speak a little bit more about himself as well, but please join us in welcoming.
Well, thank you very much. Can you all hear me in the back?
Absolutely, yeah.
Well, it was a pleasure to drive up from Toronto for my wife and my son and I this afternoon. It's nice to have a respite from seeing the natural environment consisting of concrete and asphalt. So I envy you in this beautiful environment. So I'm going to be speaking today about climate change, or perhaps the lack thereof, and basically showing you the evidence. And so the first question we'd like to address is the climate of the Earth constant? I think we all know the answer to that is no, because 10,000 years ago, where we're sitting now, we had a layer of ice covering the surface of the Earth about 1 kilometer thick. It looked a lot more like Antarctica. But that was a long time ago, so we can say, who cares about that? We want to know what happens in recorded human history. Was the climate constant during that period of time? And the answer is no. And here is some nice evidence on the left here. Here we see the remains of a Catholic church in Greenland. This was a location where the Vikings went and settled. They farmed. They have found the remnants of a few thousand farms where people farmed with sheep and goats. The climate was warmer in the northern hemisphere, and farming was possible in Greenland. Then around 1400, the settlements were abandoned. I think the last date we have is something like 1408. There was a couple that got married. They went for their honeymoon to Iceland, and the date of 1408 was stamped in their passport by the Iceland Department of Homeland Security. So for some reason or other, the Viking settlements were abandoned, we think because the climate got colder and farming became unrealistic. In fact, in Northern Europe, we had the Little Ice Age, a period from about 1400 to 1800, rivers such as the Rhine, the Thames regularly froze. And so here's a nice iconic painting done by Hendrik Averkamp in 1608. If you look closely, I don't think you could see it too closely. I'm always a little leery of showing this in Canada because you see some people playing hockey. But I usually get audiences are reassured when I tell them these gentlemen were the great-great-great-great-grandfathers of Bobby Orr.
Yeah.
So climate is not constant. Now, of course, what we're here today to discuss is what's happening to the climate as a result of the use of fossil fuels that generate greenhouse gases, most importantly carbon dioxide, methane, and nitrous oxide, or N2O. And there have been some very nice measurements made of these concentrations in the atmosphere. CO2 has been going up. Here we see measurements from 1960 to about 2020. It's gone up from about 320 parts per million to about 420 parts per million. It goes up by about 2.5 parts per million, basically because we're using oil, natural gas, coal. You also see the line wiggles a little bit. The reason for that is when we get summer and spring in the northern hemisphere, the plants start to grow and they suck out the CO2. CO2 really is plant food. Now there's more land in the northern hemisphere than in the southern hemisphere. So there's going to be a net change in the amount of CO2 from winter to summer. So that's responsible for the little oscillation on that curve that is steadily increasing. Methane has gone up also, but notice it's kind of plateaued in the late 1990s, early 2000s, and we don't know why. The only reason that I've heard is, well, us Westerners went to Russia, and Russia had some leaky pipelines. The communists couldn't do anything right. And then we told them how to make pipelines leak-proof, and then they didn't leak, and that's why methane stopped going up. Well, I'm not entirely certain I buy that argument. I would love to see some measurements of the methane concentrations near where those leaky pipelines in Russia were, and I've never seen them. So it was going up, it plateaued in the late 1990s, and it's gone up in the last decade or so. Nitrous oxide, this comes largely from fertilizer use. This has gone up from about 320 parts per billion. These here are parts per million. So 320 parts per million to 330 parts per million. Sorry, 300 to 330 parts per billion in the last 40 years. And this comes from fertilizer use. Now, of course, the buses that people say these are greenhouse gases. That means they can transmit visible light, but heat they absorb. So they prevent heat going from the surface of the Earth back to outer space. And this is, the theory goes, causing some warming. And so here we see the temperature change from 1850 to 2025. So this goes from about -0.75 degrees to 1.25 degrees. Now what is interesting about this graph is you see from about 1900 to 1940, the temperature went up by about 0.5 degree. Now, no one really knows why that occurred, because during that time, greenhouse gases were not changing very much. So probably this is not due to greenhouse gases. This is probably just some warming that continues after the end of the Little Ice Age. Then from 1940 to about 1980, temperatures remained flat. Maybe they decreased slightly. We don't understand that too well. The thinking is, well, maybe there was a lot of pollution, and the pollution acted to prevent global warming from occurring. And so then the theory goes, well, in the 1970s, we in the West, we became very concerned about pollution. We had a lot of pollution controls. The air got cleaner, and sure enough, then the temperature after 1980 went up because we had cleaner air. The problem with that is if you go to India or China, after 1980, the air did not get cleaner, it got much, much dirtier. So this idea that we in the West control everything, I think requires some caution. Then from about 2000 to 2016, surprise, surprise, temperatures remained flat. This was completely unexpected. None of the models, which I'll be talking about soon, predicted this. And this is known as the global warming hiatus. And so you had conferences devoted to why did this occur. In the last few years, we've seen an increase. Last year was a warm year. It was one of these El Nino years. You have this big blob of warm water in the southern Pacific, and this causes warmer temperatures around the Earth. So the point I'm trying to make here is that CO2 has been rising steadily, as have N2O, and yes, methane has been going up. Temperature, on the other hand, goes up, flat, not quite the same pattern. So there's more to temperature than just saying what's the CO2 concentration. Now I refer to these models, and there is a United Nations group called the Intergovernmental Panel on Climate Change, and they've been trying to make sense of what's going to happen with the world temperature. And so they have very elaborate computed models, and they've made predictions of temperature warming from 1975 all the way out to 2020. And that's basically this spaghetti here. So there are like 50 different computer models. And that spaghetti is difficult to interpret. So if we take the average of all those models, we get these nice little red or yellow dots. And here's a line put through the average of something like 50 of these computer models. Now the question is, what were the observations? And the observations here are in green. And so it doesn't take a rocket scientist to immediately see that the green line slopes up much less than these models. So the models greatly inflate how much warming there has been. This is well known that there is this hot warming problem with the models. Much of the reason probably is because clouds are very difficult to model on the computer. Now, what have we done? I've worked with Will Happer at Princeton, and we generated this graph. So what we've done here is we plot heat. This is heat measured, say, by a satellite versus color or frequency. Now, these colors are in the infrared, so this is not colors that you can see. Your cat probably can see a little bit in the infrared. So you can think of these as infrared colors. Now, if there were no greenhouse gases, then what your cat in the satellite would see is this nice blue curve, this nice bell-shaped or funny bell shape with a tailed curve. Now, if I add the greenhouse gases, water vapor, CO2, ozone, methane, and nitrous oxide, I get this black curve. Now, the reason for the difference between this nice blue curve and this ragged black curve here is because there's a lot of absorption of the infrared heat by water vapor. This big dip is due to CO2. Here, this second dip, that's ozone. This here, the difference between the blue and the black curve, that's mainly due to water vapor. A little bit due to methane and nitrous oxide. If we double the CO2 concentration from 400 to 800 parts per million, we get this red curve. And you notice the red curve and the black curve nearly overlap. The difference between the red curve and black curve is what the fuss of global warming is all about. If we have 0 parts per million CO2, we get the green curve. So this clearly shows this is what carbon dioxide is doing. It's absorbing infrared light of these frequencies, about 600 wave numbers. Now, you're probably thinking, William, that's a nice curve, but why should I believe you? And that's a fair question to ask any scientist. And the answer is, well, we're going to look at observations, and we're going to show that we can account for those. So here we have our satellite with our cat looking down. Here are the observations. So this is intensity of the heat coming to the satellite versus frequency or color. And so here we see for the Sahara observations, this is what we calculate. Looks pretty similar. For the Mediterranean observations, here's what we calculate. You can't see the scale, but these numbers here are not as high as for the Sahara. The Sahara is warmer, so you're going to get more heat going to the satellite. than when you're over the Mediterranean. And Antarctica, here are the observations, and here is our model. We do not have any fudge factors in our calculation. So we're kind of pleased with this agreement between the model and observation, and that indicates that we have some understanding of the situation. Now let's try to understand how much of the warming is due to each of these greenhouse gases. We're going to assume that the warming in the 21st century due to greenhouse gases will be about 1 degree C. Where did this 1 degree C come from? Well, the observed warming in the 20th century was about 1 degree C. Probably a lot of that from 1900 to 1940 had nothing to do with greenhouse gases, but that's why 1 degree C is a nice number to pick. Now if we take, we're going to be considering carbon dioxide, methane, nitrous oxide, and then halogenated gases. Those are those CFC compounds that you used to use in your spray cans. There are a whole bunch of these gases and their replacements. They also act as greenhouse gases. Now, if I add 1 molecule of methane to the atmosphere, it exerts about 31 times greater warming than adding 1 molecule of CO2. So that's why people always complain methane is so dangerous, because 1 molecule of methane is 31 times more terrible than 1 molecule of CO2. But we are adding about 300 times more CO2 molecules to the atmosphere than methane molecules. So the net effect of methane will be the 31 divided by 300, or 312 if you look at it carefully. So the effect of methane is about 1/10 the warming of CO2. Now if you look at nitrous oxide, add 1 molecule of nitrous oxide and it exerts about 233 times the warming as 1 molecule of CO2. But we're adding about 3,000 times as many CO2 molecules for each single molecule of nitrous oxide. So the effect of nitrous oxide is 233 divided by 3125. It's about 6% of the warming compared to CO2. If you do the same calculation for these CFC type compounds, you get a contribution of about 0.02 degrees C per century. So CO2 warming per century about 0.83 degrees C per century, methane 0.08, N2O 0.06, and these CFC compounds 0.02 degrees C per century. If you look at your thermometer, I think you'd be hard pressed to measure 100th of a degree.
What about water vapor?
Well, water vapor we can't really control. Now, I think your question was, I'll get back to it later, is if you have some warming, does that cause an increase in humidity? And that's one of these feedbacks, and I'll be happy to talk a lot more about it later. Now, is CO2 very bad? Well, I began by saying CO2 is plant food. And here we have a little experiment. You can't see it too well, but this professor grew this pine tree in a plastic bag, and he fed into this just the normal atmospheric pressure of CO2. Here he added 100 plus 150 parts per million CO2. So instead of, say, 400 parts per million CO2, he was at 550. And you see the plant starts to get bigger. When he adds 300 parts per million CO2, still bigger, 450, so that's more than double the CO2 concentration. The plant is noticeably bigger than the ambient tree growing in ambient atmospheric conditions. So more CO2 means greater plant growth, which is great for farmers. But there's some more subtle effects. It turns out when you increase the amount of CO2, the holes in the leaves called the stomata, they shrink in size. So it's a bit like having a bunch of teenagers. If you put a lot of food in front of them, their mouths become smaller. Now, if the stomata shrink in size, that means there's less water loss from the plant. And that means the plant can grow better in drier areas. And so there have been some studies by NASA, and they come up with this. And green here means that vegetation is growing more than what you'd otherwise expect. So you see in the border of the Sahara where it's very dry, plants are starting to grow more rapidly. So the point is having more CO2 introduces some subtle effects that assist plant growth. Now, one of the greenhouse gases is nitrous oxide that comes from fertilizer use. And we can ask, why has fertilizer been used? Well, if you look at the yield, so this is the ratio of the yield compared to the yield in about 1860 or so. So here we go from 1850 to 2030. You see the yields of everything, be it corn, wheat, barley, hay, oats, rye, etc., have gone up very sharply. And the increase occurred very rapidly after World War II when people started to use better seeds and also fertilizer. So if we say we are not allowed to use fertilizer, and yes, some countries, prime ministers want to say that because they don't want to have nitrous oxide increasing in the atmosphere, that means you're going to have a drastic decline in the world food supply, probably even famine. And what increase in temperature are we looking at? Less than 0.1 C per century. I would argue having a stable food supply certainly is better than worrying about that. Now, if you have a warming temperature, there are all kinds of effects that you can expect or predicted. One is that you get less ice. So I think you're all familiar with the Arctic ice disappearing. You have the lonely polar bear struggling to remain afloat on a little ice floe. We've been measuring the extent of the Arctic ice from 1979 onwards. It goes up and down. The minimum occurs in September. The maximum occurs in March. So here you see this going up and down. And then I put a blue line on the average March extent trend, and this red line is the average extent in September. And if you were to continue this red line, you would hit zero ice extent in September of something like 2075. But if you look a bit more carefully, and you look at from about 2007 on, and then you just fit those September ice extents, you just get a flat line. So we don't quite understand what's going on here. The Arctic ice did go down noticeably in the 1990s, early 2000s. But in the last 16 years or so, it seems to have stabilized. Nevertheless, there has been a decline in Arctic ice. And this has some dramatic observations. I thought this quotation was interesting. The expedition sailed as far north as 81 degrees, 29 minutes in ice-free water. So this is very far north. The Arctic is not recognizable as the region of the previous 50 years. Glaciers have been replaced by mounds of earth and stones. Great shoals of fish have disappeared, and the seal population has diminished. And this was by G. Ift, entitled The Changing Arctic, in the Monthly Weather Review, page 589. Whoops, I forgot the year, 1922.
Oh, wow.
So the Arctic has changed in the past. There have been warm periods, some followed by cold periods, and we don't quite follow that. However, our ice extent has changed. For example, if you go to Banff National Park, I'm sure you can see the dates of the retreating ice. One of the best places to see the retreating ice is in Glacier Bay. I have a sister-in-law, one of these rich accountants who retired and could afford to go on a trip to Glacier Bay, Alaska. And apparently it's really nice to see. You see some beautiful pictures of glaciers. The first cruise was done by Mr. Vancouver in the late 1790s, although he couldn't get far because the ice extended all the way to the Pacific Ocean. And they have mapped out the decline of this Arctic ice. Each of these red lines are a different date. And you see that Arctic ice has retreated by about 100 kilometers. Much of that retreat has occurred during the 1800s when greenhouse gases were not changing significantly. So there has been a retreat of glaciers, but much of this is due not to increased greenhouse gases. Now, of course, if you have a decrease in ice, that goes to increase in sea levels. And some of you probably recognize that my name is Dutch, and one of the questions I get often is, William, why are you so tall? And I explained that my ancestors came from Holland and the short ones drowned. If you look at the map of Holland, about 500 BC, it looked very different than what it looks like today. In fact, today, all those purple regions are below sea level. If you did not have dikes, you would have fish swimming there. It's about 4 to 5 meters below sea level. So this area here was very marshy. Romans have given us accounts. They would be in their heavy armor chasing a barbarian, and then they would sink into the swampland. So we have had an increase in sea level about 5 meters over 2,500 years, and that works out to something like 2 millimeters per year increase in sea level. Now, a more recent measurement is here sea level from about 1860, sorry you can't see that too well, to the present day. And this blue curve is the measurements. These measurements were taken up here, placed in Friesland. And then they fit a nice line through it. And this line slopes up at 1.5 millimeters per year. So this is entirely consistent with the increase in sea level we would get from those two maps. Also shown on this bottom graph is the CO2 concentration in green. My apologies for the poor view graph. So this CO2 has gone up from about 280 parts per million before the Industrial Revolution to about 420 parts per million right now. Now, the point of having those two curves on the same graph is that here you see the CO2 going up dramatically, but the sea level just seems to be going up at a steady pace. So again, CO2 does not seem to be causing an acceleration in sea level. Now, the reason I trust the Dutch very highly is if you're a Dutch person and you get this wrong, your family drowns. In fact, in the 1950s, there was a big storm, and some of the dikes surrounding where my parents grew up burst. And when Canada heard about it, they expedited their application to immigrate to Canada. So I guess I'm descended from some of the world's first climate refugees. Now, if you're a farmer, it's not just temperature that worries you, it's also adequate rainfall. And so the worry is, if we have a warmer atmosphere, does rainfall change? Well, I looked at some data. This is from the United Kingdom. Here we look at the percentage change of precipitation from 1700 to the present day. This red curve is just the average of 5 of these angled black dots. And basically, in England, precipitation doesn't change. It's just very reliably wet all the time. If you look at India, Pakistan, you see a lot more fluctuation. In fact, when I was doing this, I noticed 1900, only half of the annual precipitation. I thought, how can that be? And so finally, I Googled 1900 India famine, and it came up right away. The monsoons failed. And as a result of this, several 100,000 people, maybe even 1 million people, starved to death. It was terrible. So I was walking across campus a week or so later, and I saw my friend from engineering, Jay Sharma from India, and I said, "Chief, I looked at the precipitation records in India, and I saw in 1900 there was a terrible famine." And he looked at me, "Of course, William, every school child in India learns that, didn't you?" And I had to kind of cower and say no. And 1900, we were told at my British school was that Queen Victoria was dying. So this certainly agrees with historical history. In the US, if we exclude Alaska and Hawaii, no dramatic change. If you look at California, you do see a lot more fluctuation because California, much of it is a desert. Some years are very dry, some years are very wet. However, from 1850 to the present time, you don't see any trend. Now, one of the things that you probably have heard about is wildfires. I think last year was a terrible year. So here we plotted, red is the area burned, black is the number of fires, and up here we have Canada. And you see from 1990 to 2020, some years you have more forest fires, more is burned, some years you have less. I wanted to update this to get the statistics for last year. I couldn't get that. But I'm sure last year would be way up here. But please keep in mind there are other years that were way up and others are way down. Closer to home in Ontario, the same thing. Some years you have more forest fires, some years less. No overall trend.
Excuse me.
Yeah.
What consideration is given to deliberate?
Well, there's a lot that goes in here that you would expect there to be a trend due to humans. So, for example, one of the things we've been doing is trying to suppress fires. And if you suppress fires very successfully, you get a buildup of flammable material, and then you're going to have a year where you get extraordinary amounts of fires. You have other effects, like you can have campers going in there and setting blazes. So the point of this is not to show that there's no human effect. But what the climate change people, or some of them like to claim, is that there's been a dramatic increase in forest fires due to climate change. And what I'm trying to point out here, there is no recognizable increase in either the area burning Now, one of the things that people have said is if we have more greenhouse gases, we're going to get more storms, more extreme events. Well, what are the big extreme events that you consider? Obviously, hurricanes. So here we plot the number of all hurricanes from 1980 to the present day, up here. Some years you have more, some years less, no overall trend. And here you have major hurricanes, which have much higher wind speeds. You have fewer of them, again, some years more, some years less, no overall trend. So nothing's happening there. Another extreme event is tornado. Now here we plotted a number of tornadoes from 1995 to 2020. The reason we've taken that segment of time is the measurement instrument remained the same. It's what they call the Doppler instrument, which measures your wind speed. This didn't exist in the 1980s. So when you're looking at the number of events, you like to make certain that the instrument remains the same, because if you change instruments, you can get a change in how efficient the instrument is at detecting something. So if you look at the number of tornadoes from 1995 to 2020, some years a few more, some years a few less, nothing going on. If you look at the strongest tornadoes, the same story. No overall trend. Now, one of the things that people have said is if we produce more CO2, a lot of the CO2, up to half, goes into the atmosphere and goes into the oceans. And when it goes into the oceans, it creates something like carbonic acid. So the story goes, what we're doing is we're slowly turning the oceans into pulp, acidifying them. And we all know if you put a fish into stomach acid, they get seriously unhappy. So the pH scale is what's used to measure acidity. When it's neutral, like distilled water, we're at 7. Bleach is about 13. Stomach acid about 2. And so we've done the calculation. If you double the amount of CO2 in the atmosphere, the pH will be reduced by about 0.27 of those pH units. Now, how does that compare to the real world? Well, here are some measurements taken at Santa Monica. This is a place in California from about 2000 to 2006. So you can see it takes about 6 years to get your PhD at Santa Monica. And what they've done is they've taken a PhD student, tied a thermometer, a pH meter to him, and then he goes up and down like a yo-yo for 6 years. And you can see here, orange, that means there isn't that much CO2, because near the surface there's a lot of sunlight, you get a lot of plants growing, and the plants suck the CO2 out of the water. It's only when you get deep down, where there are very few plants that suck the CO2 out, that you get more CO2, and you get a slight increase in acidity. So you can imagine if you have a sunbathing seal, and after an hour or so she gets hungry, she dives down 50 meters, she's going to experience an increase in acidity of a few tenths of a pH, comparable to what you'd expect if we double the CO2 concentration. Seal isn't doing any badly due to that change in pH, nor will we. So our conclusions. If we extrapolate the observed 20th century warming of 1 degree C to the 21st century, and now I'd like to get back to the very good question someone asked about water vapor. That 1 degree C, that presumably includes an increase in water vapor triggered by those increase in greenhouse gases. So when we say 1 degree C increase, that includes the effect of water vapor increasing possibly due to those increases in greenhouse gases. We've also calculated in detail, but that gets a bit beyond the scope of this talk. I can talk to you afterwards if you wish. The amount of warming for CO2 we expect will be about 0.83 degrees C per century, methane 0.08 degrees C, nitrous oxide 0.06 degrees C, total warming about 1 degree. If someone says, William, I don't like your 1 degree, this should be 1.5, then multiply all those numbers by 1.5. For example, 0.08 times 1.5 gives you 0.12, still very small. 0.06, 0.09 degrees C per century. Canada's fraction of emissions, 1.5% of the CO2 in the world comes from us, about 1.1% of methane, 1.4% of N2O. So if we multiply these two numbers together, then we see Canada causes about 0.012 C per century warming due to CO2, 0.0009 degrees C per century warming due to methane, 0.0008 degrees C per century warming due to nitrous oxide.
The calculation of methane, is that including the methane that's being released in the Arctic where soils are being exposed as a result of the retreat of the ice?
We're using the global emissions due to methane, so that includes that effect, it includes leaky pipelines, it also includes methane which comes from burping cows. Cows eat grass and then they chew their cud and then they release methane, so it includes all of those effects. We have also in our calculations said let's presume that methane continues increasing at the rate from 2003 to the present time, where methane was going up. If you consider that earlier period, methane was flat. So we have taken the scenario that makes this number for methane as large as possible. The evidence doesn't support any hysteria about droughts, floods, polar ice, glacial retreat, sea level rise, etc. There is some warming, however, it is modest. And I would argue if you're a Canadian and it is minus 30 or minus 40 degrees C outside, and you don't want to burn your furnace because you're afraid of global warming, that's fine, but you probably are going to freeze to death.
Right. Yeah.
And if you're worried about this nitrous oxide increasing, which is at this very, very tiny rate, you can of course not use fertilizer on your garden. You cannot use fertilizer anywhere in Canada or the world, and then a lot of people are going to starve to death as well. That's probably going to be silly as well. So outlawing fertilizers, reducing herds, which is now being talked about actively in countries like Ireland, Holland, and I believe also in Canada, negligibly affects the climate and endangers the global food supply. There also are unintended consequences. If you take, say, a hectare of very fertile land in Canada or Holland out of production, people are going to eat. That means they're going to turn some of the Amazon rainforest into farms. that land in the Amazon is not very fertile. So if you have, we'll say, 1 acre in Holland, you might need to have 10 acres in Amazonia. And of course, those 10 acres in Amazonia, after a few years, you have to replace with another different 10 acres of Amazonia. So those policies may inadvertently do great damage to the ecology. So the world is not close to a climate crisis in 10 or even 100 years. So net zero just is not based on science.
Question.
Yes.
Was any consideration taken into what they term aerosol injection?
Well, the aerosols is something that people don't understand very well. The idea is that if you look at the graph of temperature over time, you see that the temperature kind of remained flat, maybe even dipped slightly from 1940 to 1980, and that's all pollution, or what they call aerosols. That's fine, but when I ask, okay, can you tell me which aerosols, can you give me the concentration versus altitude of these various aerosols? Can you give me the colors or frequencies that these aerosols absorb? Then all of a sudden, well, we don't have data for that. We have some model data. And of course, if you say, well, okay, you have model data, but you'd like to back that up with observations, and then they say, well, that's why temperatures remain flat from 1940 to 1980. It went up from 1980 to 2000. Again, my point is that the aerosol number over India and China went up dramatically. The big problem with that argument is after 2000 to 2016 with the hiatus, none of the models, which presumably understood aerosols, predicted that hiatus. So that's why aerosols are frequently invoked as an explanation for things, but they are not well understood, and the models have not yielded results that have useful predictive power.
Question. How come vapor trails behind the airplanes that used to be really tiny and now they go across the whole length of Muskoka?
And that my question was aimed more at the spraying in the air. But was anything taken into consideration for any of these studies with the chemtrails that are being distributed?
Well, the contrails, I know a little bit about that. First of all, I question if there's been a dramatic change. Maybe there's been a change in the size of the airplane or the size of the airplane engine. But the basic chemistry in the atmosphere responsible for contrails generation would have been the same 50 years ago as now. One of the things I did which got me a bit of notoriety was one evening I was a bit tired, so I turned on the television set. And being a scientist, I want to act like I was still learning. So I turned it on to Frontline, one of the, or Nova, one of the science shows on public television. And they began with dramatic evidence, footage of 9/11. And in 9/11, the airplanes crashed into the Twin Towers in New York City. And then for 3 days, there was a ban on flight travel in North America. So there were some scientists who said, hey, this is a great opportunity for science. Let's see what the effect of these contrails were. And they looked at the temperature, the difference between the average day and nighttime temperature during the flight ban and the 3 days before and after the flight ban. And they found a 1.5 degrees C, or something like that, change in those periods of time. And this was evidence of how terrible the contrails were, how terrible man was. And I looked at this and I thought, hold on a second. I was working at Environment Canada trying to analyze temperatures, and I saw over a few centuries, I could just see a 1 degree C increase in temperature, consistent with what other people are finding. And now there was a group that said all I had to do was turn off a few hundred jet engines and I'd get a comparable temperature effect in just 3 days' time. I thought that doesn't make sense. So I went and looked at it a bit more carefully. The first thing I did is I didn't just look at a 3-day average. I looked at what happened in each 24-hour period. And I saw this change in the day to nighttime temperature started before the attack on 9/11. And it also was ended before the flight ban was lifted. And then I looked at the cloud cover in North America. And you could see through each of the 9 days, 3 days before 9/11, the 3 days through the flight ban, 3 days afterwards, that there was just a change in cloud cover as you went through those 9 days. And I was giving this talk, and then someone said, you know, William, it kind of makes sense. Osama bin Laden's pilots were not very good. They needed clear skies to get to New York. So contrails do have an effect. However, it is small. And I think people have to be a bit cautious, after 9/11, with making claims that they are they have a very good effect.
So there was a study during 9/11, what happened in those very few days. There's been some major observations during COVID when there was no air traffic for, I can't remember the timeline, if it was weeks or a month or two. And I remember specifically seeing crisp blue skies day after day after day after day, to the point where actually, when my wife and I would normally be out on the water, we would never burn. But this one particular summer, because there was no flights in the air, we were constantly getting a sunburn.
Well, I haven't looked at that. I did look at 9/11. There was also a few years later, there was a blackout in Ontario when they were all in the eastern seaboard. I forget exactly what happened, but I know in Toronto we basically had no power for a few days. And so I looked, is there an effect then? I didn't find anything. I have not looked at COVID. Of course, there was a lot of things that went on in COVID besides less airplane traffic. So I really can't address that at the moment. I don't know where to start.
You keep saying contrails. When you say that, what exactly does that
Oh, so when you see an airplane, sometimes you see these white little vapor trails. That's what's known as a
I'm coming to
contrail.
that. Which is condensation trails. That's why
Exactly.
that should not to be. But the actual deliberate delivery of chemicals in the air.
Yeah, it's called cloud seeding.
Cloud seeding.
Yeah.
Is that happening, and why is that happening, and who authorizes this?
Well, there is not much cloud seeding happening, and my knowledge of it is that it is not very significant, as it turns out, affecting the climate.
Is it
I
effective?
think whether it's effective, I'm not familiar with studies that really show it's very effective.
I'm sorry.
Now, there is a proposal to say, let's have a bunch of 747s fly nonstop, 24/7, producing a lot of these aerosols, these sulfite particles. And these would basically act as high altitude reflectors of sunlight. And if you have a fleet of, 100 747s flying 24/7, you could conceivably affect the climate. A number of people, including myself, find that's a very dumb idea. If you put in a lot of these sulfate particles, I'm sure there's going to be some unintended effects, like more sulfuric acid rain, and those would probably give you a much greater headache than anything you're trying to fix. Go ahead.
So throughout Canada, all the municipalities they want to spend billions to fight this climate change emergency. Can you take any of this and can we take something and bring to our local municipalities to show them? I don't know if they're going to listen, but we have thousands of real scientists saying there is no emergency, and they want to base everything that they're doing on this so-called climate change emergency.
Well, let's take the extreme case. Let's suppose tomorrow that a police car stood at every gas station saying you're not allowed to fill up, that the natural gas pipelines from Alberta are shut off, that you're not allowed to use fertilizer. What's the warming? We're talking about 0.014 degrees C per century, less than if we continue as you can't measure it.
So
So that's just the point.
But how do you get that across to these mayors and councillors? And I mean, they're absolutely mad about saying we must fight climate change and disregarding our infrastructure, looking after our seniors and veterans, our children, and housing, everything. I mean, they're writing a blank check for climate change.
Well, maybe I can ask your question in a slightly different form. And that is, William, if what you say is true, why haven't you been able to convince these politicians that what they're doing is silly? And I'm not entirely certain why we haven't been able to convince them. I suspect many of them have not heard the talk or something similar to what I just gave, or
But
some of my colleagues.
You actually did bring it up when you were talking about fertilizer. So you said if there's a decreased amount of fertilizer, that means there's going to be a decreased amount of food.
And cause famine worldwide.
Cause famine worldwide and starvation, which is part of the WHO, the WEF and the WHO agenda, is to depopularize the world.
Well, I'm not that familiar with the WHO. Certainly this experiment of not using fertilizer was done 2 years ago in Sri Lanka, where they had a government that bought into this idea that and this nitrous oxide was very bad, so let's ban fertilizer use. The food supply decreased sharply, and there was a revolution in Sri Lanka, and the president or prime minister had to flee for their lives. So I suspect that many of these policies are going to die a death where people just see it's completely impractical. People want to eat. Also, if you are in the third world, you're not going to pay any attention to people in the West saying you have to limit fertilizer use, you can't use fossil fuels. People in India want the Western standard of living, and they are going to burn coal to generate electricity, same in China. So what we do in the West is largely irrelevant. I don't know if I've answered your question.
Well, it's a big question, and yeah, people are doing delegations, and I mean, whether these mayors and councillors are going to look at anything, I mean, they have families too. They have grandchildren.
Well, I suspect that things are changing. I know I visited Holland a few months ago, and there the politics, they had an election, and this group that was very strongly opposed to some of these extreme environmental agenda, they did very well.
Yes.
And I suspect in many of these countries, you're going to see turnarounds. I think even in Germany, which had been very strong in favor of these wind turbines, solar cells, which are great, but unfortunately don't produce electricity reliably enough to run an industrial economy. That didn't work when they had this natural gas shut off from Russia, so they started to burn very dirty coal. Very bad for the environment. You get pollution, obviously. So people are going to demand electricity. If food prices go up, if energy prices go up too much, people will rebel. I don't know where. Could I go here first? And I'll come
My
back
question is about the ozone.
Yes.
Okay.
What happened to it?
So ozone can be damaged by chemicals that we're using, but it can also be damaged by the sun's activity from the other side, correct? And if it is correct, if the ozone is depleted, does that not expose us to radiation that otherwise wouldn't be entering and causing a heat?
Well, there was a lot of concern about the depletion of ozone, I guess, in the 70s and early 80s, and the measurements did show that the amount of ozone was going down, and that meant that more ultraviolet light can reach the surface and cause sunburn, eventually skin cancer. So as a result of those studies, they sharply curtailed the use of these CFC, chlorofluorocarbon compounds, which were used in air conditioning spray cans. They are monitoring the concentrations of CFC11 and CFC12. Don't ask me the chemical formulas offhand, I have it in front of my papers. But those concentrations have been going sharply down over the last 30 years since that so-called Montreal Protocol. This was an agreement, I think, around 1990 to sharply curtail the use of those CFC compounds. And so those compounds, their concentration has been going down, and it seems that the ozone has been recovering, that there's more ozone in that upper stratosphere where it absorbs the ultraviolet rays from the sun. So I don't believe that is of great concern anymore. Yes?
I want to go back to the chemtrail agenda. Sorry. I believe there's been an accelerated amount of chemtrails being released in the air. To the extent that Louisiana, the state of Louisiana has banned it, and Mexico has taken a stand against the geoengineering and chemtrails in their skies. It's been my experience. Last summer, I drove out in May of last year. I drove out to Manitoba, and the unprecedented number of trails that were across those skies, just crisscrossing for hours, day in, day out, and the skies would suddenly have a satin blanket fill of clouds over there. And I suspect a lot of that is happening here in Ontario. So to suggest that there's very little of it, I beg to differ on that, and I wish to have to speak on that.
Well, I think your question could be asked more generally. What is the effect of clouds?
Clouds.
And that is very difficult to answer. Because if I am on in a bright sunny day and a cloud comes and blocks the sun, the temperature goes down. So clouds can have a cooling effect.
Yeah.
However, if I'm at night and I have no clouds, like say no clouds tonight, then a lot of the heat from the surface can just go out to outer space, and I get very cold weather, maybe even a frost. So clouds can have warming and cooling effects, and these contrails are an example of a cloud. And that's why understanding the role of clouds, that can be very tricky.
To contrails from chemtrails.
Or chemtrails, whatever.
Chemtrails is the deliberate release of chemicals in the air.
Well,
I think we're confusing, excuse me, I think we're confusing two things.
Yeah.
Our scientist guest is obviously an expert in the greenhouse gas effects, and that's what he's addressing.
Yeah.
And you're speaking to something that I'm on the same page as you,
But
and it's controversial, that there is a program that is nefarious of corporations and governments arranging to have toxic metals and deliberately dangerous chemicals added, deliberately sprayed to poison the population.
well,
I personally don't want to put you in the position
Okay.
of having to be the arbiter of that, but that's why we're having this
Okay.
disagreement.
I am not familiar of any government that is purposely trying to poison its people by putting these dangerous chemicals in the air or whatever. I'm just not familiar with that. I don't think that's.
I'm not suggesting that, but when in your research in researching air particles, environmental issues, whatever it is, one might find, or I'm asking whether there's been any evidence then of an increase of whatever it is being released in the atmosphere. And that's maybe where I was maybe suggesting.
Well, I'm sure that the techniques to measure impurities have gotten better and better, so I'm sure that you can get more and more measurements of impurities in the atmosphere, but those concentrations tend to be very tiny. However, what I think you're putting your finger on, which is a big one, is the effect of clouds, and that's one I didn't speak too much about tonight, but that's the one that I'm actively pursuing. If you have no clouds in the sky, it's very easy, or relatively easy, to make calculations about how heat goes from the surface through the atmosphere to space. When you have clouds, things get very complicated. And what can make things even more complicated is if, as a result of a slightly warmer atmosphere, you get a slight increase in cloudiness. And that can cause, counteract so-called global warming effects. So clouds are the number one uncertainty, and that's the number one problem with the accuracy of these global climate models. Back there, I see.
How do you, when it comes to the CO2, CH, and the N2O, how is that actually measured in such tiny particulate quantities? How is that guaranteed to be accurate? Like, how is it actually, what's the process? Because it's pretty microscopic.
Well, there are a number of ways you can do it. No, those measurements, which I showed at the beginning, let's see. Those have been carefully checked. In fact, you could say, does it depend where you measure it? Obviously, if you put your meter at the top of the smokestack, you're going to get very high CO2 parts per million. In fact, I wish I'd taken my CO2 meter along. You can breathe into it, and then you can just see the setting, 800 parts per million. There are a variety of ways you can do it. For example, I could take a bunch of a dewar of air, freeze it, and see at what temperature the nitrogen freezes out, the CO2, the water vapor. That would be one way to do that. So those have been very carefully tested, and no, I'm convinced those are very reliable.
No, I go back to this one process, so it gets read through a meter that it's blowing through, and it can read the different particles?
Oh, I have a meter I wish I'd taken along. It's like a breathalyzer. You blow into it, and then it just reads it out.
Cool. Okay.
And then it's kind of interesting. If I have this meter in a room like here, it reads, say, 800 parts per million. If I take it out to a fresh air outside, then it's going to be much lower because there's less hot air being produced. Yes?
I don't know if you have the number off the top of your head, but one of the slides you might want to add to your deck is one that I've seen that's very powerful, where it's a pie chart, and I'm sure you've seen it, and it shows the amount of CO2 in the atmosphere, and it's, I don't know, it's 0.7, less than 1%. It's a very tiny
0.04.
tiny sliver, and then the human contribution of that to that is a really tiny sliver. And even though that doesn't necessarily mean CO2 couldn't have an effect on temperatures, I think that chart really powerfully gives people, like, they don't put that in the Toronto Star, you know?
Well, I understand the point you're making, but, you know, just a wee bit of cyanide can also be very bad. So just because something's very small doesn't mean that it is negligible. So I want to be a bit cautious with that. But it's when you do the calculations to see the effect of CO2 doubling and to see that is small. That's what thinks.
They've asked politicians, they've put them on the spot and said, what percentage of the atmosphere do you think is CO2? And they think it's 20%, 30%.
Yes, I'm well aware
no
of that.
idea. So when you give people that reality check of this vanishingly small trace gas, I do think it's important to give
Well,
them.
I would hate to say that people should make a decision about whether to believe global warming based on how dumb a politician is.
Okay.
I'll be happy to stay afterwards and have private conversations.
I think, yeah.
Oh,
Okay.
one more.
I have a question.
One more.
It must be very concerning for you to have this knowledge with your expertise, and there most likely as other scientists you have such a point of view. Is there any movement through scientists and people with your expertise to bring it to the government to stop this and stop the carbon tax and what it's doing to our society?
Well, first of all, I'm a scientist, so when it comes to tax policy, you know, I think you need an economist to say balanced budgets, etc. I can't comment on those. Where we can comment on is that if you were to eliminate some of these fertilizer use, natural gas, etc., what that'll do to the climate, and I think I've tried to show that is negligible. There are a number of us who feel that way and who are trying to convince governments. We're trying to write op-ed articles. Some of us have testified before various political bodies such as the U.S. Senate. I think the question that some people may be asking, that your question kind of alludes to, is we see all these reports about a consensus of scientists say such and such. And I always get a bit nervous with that because science is not based on political opinion polling. When you were in grade 1 and the teacher said, what is 7 times 8? You didn't take a poll of your classmates. You looked at what the one geek in the class was going to say. Secondly, there's this report that 95% of scientists believe in global warming. I don't know what that means. I guess I'm one of the 95% because we've shown if you increase greenhouse gases, there will be some warming. However, that warming is modest and the world is not going to come close to ending in 5 years, 10 years, 100 years.
There's no emergency.
So that's right, there is
That's
no
right.
emergency. So by trying to show the data in a very passionate way, I hope it's been passionate, we try to show people, look, there's been no change in number of tornadoes, no change in number of hurricanes. Sea level's been going up, but it's been going up for the last several thousand years. We ought to calm down, and hopefully that will result in a rational discussion and rational political decisions. So that's the best answer I can give you. Could I take one more? I saw this gentleman wanted to discuss.
Actually, along the same lines, I was wanting to follow the thread that the gentleman with the black hat pointed out. You're here more or less saying there's no crisis. What we hear on the news is what the government wants us to hear. Are there more people like yourself that are out here doing these sort of talks? And if so, how can we get the message, like how can we present that to the town, the government, and put a stop or put the brakes on this agenda where they're going to tax us to death? And
Well, again, I'm not an expert in political activism.
no,
a
I'm
scientist,
just wondering if
but-
we can.
Maybe we can quote your periodicals and bring them to our council and present them.
You're welcome to use whatever I've said or produced. I have a website where various things are on. You're welcome to use that. I think my colleague in the States, Will Happer, he's argued very strongly for a red team, blue team approach. And what that means is he would have one team, say Al Gore and company, make a presentation about why climate change is true and the terrible ways. And then someone like one of us would come and rebut for half an hour. And usually the climate people don't want to do that.
That's
I
right.
think they know when you show the data, they're just going to be blown away.
Yeah.
But I think by just showing the data, trying to be reasonable and dispassionate, sooner or later people are going to get sick and tired of hearing these claims that the world is going to end in 5 years, no, it's going to be 10 years. When these predictions are made and nothing happens, I think the movement will tend to fizzle out of its own
I
accord.
hope so.
At least I hope so.
Can I suggest that, would you be willing to do a video that we could bring to our municipalities and ask them to watch it as you're addressing this and condense?
Sure, I think it's being recorded now. You can
Yeah,
show this. I
we
think
will have
if
it
you,
on video.
I know there have been a number of my videos uploaded to YouTube. Anyone can get them, and I have made lots of presentations. Be happy to make more.
Thank you.
Well, we may have to bring it down to publisher Scott.
I have not heard from the Globe and Mail. Some of the people in the newspapers, there was a good science reporter, I think at the Toronto Star. He knew what was going on. In fact, he was in Louisiana at this meeting where I was giving this little paper about the contrails, and he spotted it right away, and I think then it appeared on the third page of the Globe and Mail, or not the Globe and Mail, the Toronto Star. So some of the reporters do understand what's going on. But you know, if you have to sell newspapers, what's going to sell?
Fear.
The world is going to end, or
Fear, fear,
professor
fear.
says not much is going to change.
Carry on, everybody, just carry on.
Okay, yes.
Could I could ask one story? I heard you mention of carbon monoxide. My car, before you big gas engine that runs, produces a lot of that, and I always thought that was pretty bad. Has
Well,
nothing to do with climate change?
You can have bad gases, but that doesn't mean they're greenhouse gases. So a greenhouse gas is transparent for visible light, but absorbs infrared light. And of course, we want gases having a significant concentration in the atmosphere. So carbon monoxide, you don't have to worry about for climate. You do have to worry about for suffocation, right?
Yes,
And
it's
poisoning the
space.
blood. But that's a different issue.
The gazillion cars going in the world every day, and there must be a lot of it out there, but it's not a big deal.
Well, cars have become much better at reducing pollution over the last 50 years. It's really an amazing success story.
Okay.
Can you comment just briefly on the hockey stick graph? And and again, if it's too political, fine, but that seems to be their
What's the
their
comment?
argument. The hockey stick graph, Michael Mann and his model.
Okay, well, that's why I put this graph up right here, where you see the temperature, the warming from the last 150 years. And you see this does go up, but if you look, there's this little dip here from 1940 to 1980, this hiatus from 2000 to 2016. So that seems to be a bit different than this hockey stick graph. Now, this hockey stick graph, for those who don't know, is if you plot the warming for the last 30 years, it's kind of level, and then it all of a sudden went up. And there were a number of problems with this. First of all, this didn't account for the warming of the northern hemisphere when the Vikings settled Greenland. And then someone also said, apparently it was based on some Bristol cone pine trees. So basically the idea is if it's warmer, the trees grow faster. So if you measure tree width or the width of those lines in the tree, you can get an estimate of the temperature going back in time. And apparently some people, I guess it was two Canadians, McKittrick and there was another, I forgot his name.
Patrick Moore?
No, someone else. They looked at it and they saw this, the statistics were not done very well. And this became a big hullabaloo. I was not associated with it, but my limited understanding is that when people asked to see the data, Mann was not very forthcoming. And normally if you're a scientist and someone asks you to use your data, you say, go right ahead, here it is. And so this was a bit suspicious. So there have been some people who attacked the Mann data, and one man was speaking, I guess Tim Ball, he was a professor at Winnipeg, and he was speaking before a group and cracked a joke, and he said, Michael Mann, who's a professor at Pennsylvania State University, he shouldn't be at Penn State, he should be in state pen. This resulted in a lawsuit for libel, so I have to be careful. I don't want to be
Yeah. Thank you.
Thank you.
Thank you.
Thanks a lot.
Thank you so much.